do the sign when you're ready. Can you hear me? Sound check. 1, 2, 3. Oh, dear. Sound check. Is it okay? And then we have the city buzzing. Are we good to go? Okay, perfect. Welcome to this lunchtime session on how do we measure sustainability in construction. And before we go into the discussion on how to measure sustainability, I just want to state why do we actually need to measure sustainability. And data on sustainability, it's crucial to establish a common understanding on what does good actually look like. When are we on the right path in the sustainable transition of the construction industry? And when can we claim a product or a building is sustainable? This is also expressed by the growing number of certification and labeling schemes in the industry. But we also see there are several challenges when we're discussing how to measure sustainability. How do we balance providing buyers with a comprehensive understanding of the sustainability footprint of products and at the same time also apply a pragmatic approach when handling all the decisions we need to make when designing and constructing an actual building? And we're gathered here in the Plastic Pavilion, and I guarantee today we will be talking about how to measure sustainability in plastics. But we will also have a discussion on a more systemic level on how do we make sure that we are on the right path in terms of absolute sustainability, and how does the building materials influence the sustainability of the entire building. And hopefully you will follow the discussions when we switch between the product level, the building level, and the systemic level. My name is Simone Komsbach. I'm partner in Smith Innovation, a Copenhagen-based consultancy. And we have had the pleasure of assisting the Danish Federation of Plastics in developing their innovation strategy that was also developing the work of this pavilion. And one of the innovation challenges we saw was exactly this we're discussing today. How do we measure what actually counts? Furthermore, I'm operating the Data Accelerator Indicate, where we're pushing for whole life carbon regulation on buildings by gathering and analyzing LCA data on buildings in Europe, as we've seen it here in Denmark since the beginning of this year. And I have the pleasure of moderating this session. The session is structured in 2 parts. First off, we'll have a talk by Deloitte, who's standing here behind me. Your talk will has the title, How do we shape a circular future for plastics in construction? And after this, we'll have a panel discussion where we'll dive into the dilemmas I just mentioned on measuring sustainability in construction. And luckily in the panel, we have represented both the manufacturer's perspective, consulting engineers, science, and the policy perspective. And I'll give a proper introduction to the panel after this talk. And we'll have the panel discussion, I expect, within the next 30 or 40 minutes. And now I would like to give the stage to Indy de Graaf and Michael de Grøde from Deloitte. And you are both based in Brussels, as I understand. Yes. And I really look forward to your talk, and it's based on your current work where Indy, you are engaged in a study for the European Commission on how to measure the application on circular approaches in the construction industry ecosystem. And you are involved in the European, or helping the Organization for Plastics Europe on a roadmap towards 2050 on circular plastics. So the stage is yours.
Great, thank you. Thanks everyone for coming. I think we'll start just by reintroducing ourselves. So my name is Indy. I'm part of we're part of Monitor Deloitte, which is the strategy consulting part of Deloitte, but we work as well on sustainability, in particular on the circular economy. As mentioned, we're in Brussels, so we're doing a lot of work on public policy and working with the European Commission as a key client. So we've just finished a study that I've been working on the construction industry ecosystem. And there really what we were trying to do is firstly help the EU to understand how circular is the construction industry across Europe currently, because data on this is really quite limited. So help them to understand that, but then also to develop a toolkit for industry to use with indicators that can be used by companies across the value chain to measure circularity performance. So I'll be talking about that today. And then Michael is also here.
Yes, so I'm also part of the same team as Indy. I'm working with Plastics Europe, which is a federation that represents all of the plastics manufacturers. And so we are designing together with them a roadmap towards 2050 to make plastics circular, meaning switching from fossil-based feedstock to renewable and circular feedstock. So I'll also share the insights of that study. It's not published yet, so I cannot give all of the details I would like to share, but I'll do most of it. Indy, go ahead.
Great. So we thought we'd start just by setting the scene. So maybe we can go directly to the next slide. This isn't going to be new to anyone. To remind ourselves what's driving this transition and why are we here and why are we talking about this. So we can see annual greenhouse gas emissions are going up despite the fact that we need to really rapidly decrease them towards climate neutrality. In Europe, the goal being 2050, but really if you look at global climate change, we need to move a lot as fast as we can and probably more quickly. Waste and the construction industry have lots of environmental impacts, as you'll all know, but greenhouse gas emissions is one of them. And we can see a trend moving upwards as well with the greenhouse gas emissions associated with waste and having a linear model. And then looking within the EU and looking at circular material use rate, there is some progress. So the transition has already begun. And if you look at this graph just at the EU 27, we can see overall that there's been a trend in the last decade to increase circularity. Some interesting exceptions. Luxembourg seemed to be doing very well in 2010 and are not doing well now. If anybody knows why, I'd be interested to know. There's a general trend, though. You can see that the EU public policies are already being embedded and we can start to see a transition towards circularity. And then if we go to the next slide, this is really just an overview of how the EU is grappling with climate change and the multiple negative environmental impacts that need to be eliminated. So the Green Deal, I think, again, probably everybody knows that the Green Deal is the EU's response to the climate crisis and broader environmental crises that need to be addressed, with the overall aim of becoming climate neutral, but also eliminating all negative environmental impacts, aiming at the middle of the century. So you can see in this graphic that there's lots of different domains that this covers. But in particular today, we're talking about circular economy and the Circular Economy Action Plan, which is it's the second circular economy action plan that the EU's had. And it's the main overall umbrella framework set at the EU level, which has a number of actions underneath it, including specific elements of legislation, like the new construction product regulation that's set at the EU level. And then obviously you can see at a national level how that's translated. So that's to set the scene, the overall EU framework. And now we'll dig a bit deeper into the two studies that we mentioned. So starting with the topic of embedding circularity into the construction industry. So again, some statistics to look at the EU construction industry and where it is today. There's basically two reasons why everybody should care about this beyond people, probably including yourselves, who are already engaged in the sector. One is money and one is environmental impact. So on money, the construction ecosystem within Europe contributes 11.5% of the EU's gross value added. That's a huge chunk of the economy of Europe. So it's something that policymakers beyond construction and architecture really should care about and be engaged in. And then environmental impact. So firstly, you can see on the extraction and use of virgin raw materials, currently around 20% of plastics are used in the construction industry. And you can see also other materials that there's large amounts, including cement use. So it's taking a lot of the materials that we have. We mentioned as well CO2 emissions on the first slide. So the emissions associated with waste are huge, and those can be reduced if we're reusing more materials. And then finally, a statistic that I like is that over a third of waste generated in the EU is from construction. So if we're talking about, say, circularity in plastics or circularity in general, construction is always a really big part of the story. So for our study, and if we move to the next slide, really what we wanted to do at the beginning was understand the status quo and understand how embedded circularity currently is in the construction industry before we considered recommendations to improve. And the first thing we did, I won't spend too long on this slide, but it's to understand what is the value chain, what's the ecosystem, who are the main actors. There are lots of ways of chopping this up, and I'm sure some people might have done it in different ways. But we basically broke the value chain into these different sections that you can see on the slide. And we use this to identify who are the key actors operating at each stage. And then within the study to then dig deeper into the data that they have, the kind of incentives or drivers that each of the different actors have. Architecture actually kind of spans some of the first stages that you can see here. And then some stages which are sometimes in some value chains, but not in others. So looking at demolition or refurbishment. So that was the first step. But then we realized that it wasn't sufficient just to look at value chain chunks. For construction, we also wanted to look at different levels that you have that move across horizontally the value chain, which you have here. So firstly, thinking about circularity at a construction product level or a material level, which requires different ways of thinking and systems and indicators. And then thinking about how you aggregate that up to the building or asset level, if you're looking beyond buildings. And then maybe slightly as a sidestep, looking within an organization and how an organization thinks about circularity when they're working in construction. And then finally, aggregating all the way up to the urban level and the urban system. So it's a kind of stepped approach upwards, but we looked at each level separately. So that's a bit the kind of typology and how we set out the study. We then, the first stage was, as I said, to understand the status quo. And we did a mixture of desk research and then also lots of engagement with industry. So I think we ultimately were either getting data from or speaking to over 300 companies from across the value chain. And the idea there was to generate new data that the EU could use to better understand circularity within the industry and how embedded it is. I'll talk through some of the numbers, but I think the overall point is that the picture's a bit better than we thought. So I think, as people will know, reporting and measurement takes resources. And so sometimes that's not done. But it doesn't mean that circularity approaches aren't already being embedded or considered. So as we will see from these numbers, in a lot of cases or higher cases, there is circularity happening, but it's not yet being reported in a routine way. So firstly, from the desk research, we found that 81% of companies were carrying out sustainability activities. Maybe that number's a bit low compared to what you might expect. And 68% of the companies that we looked at were also saying that they had circularity activities, even if these weren't properly reported. And then a much lower number, 38%, were actually properly measuring and reporting against indicators on circularity. We carried out 2 surveys to kind of test this desk research. The numbers are quite similar. So also about 70% of companies said that they were already embedding circularity approaches. 62% said it was a high priority, circularity. Again, maybe that's a bit low, but I think then another chunk said it was quite high, and a really small amount just didn't think it was a priority at all. And a slightly smaller number from the survey were actively measuring circularity, so 25%. So we can see that measurement is a challenge here and access to data, but there's a lot of engagement to try and make the transition and make the change. So if we move to the next slide. So what we then did in the study was to think about how do we address that measurement gap, and how do we think about how companies can take maybe easy steps to improve circularity. So the one thing we did here was define different circular approaches in the context of the construction industry ecosystem. And we also did a bit of research into which of these approaches are currently most adopted. you find a lot of these, and you can see this if you can see on the graph on the right, a lot of these approaches are in more the design stage, and there's maybe not enough at end of life and reuse and refurbishment. So particularly thinking about recycled and secondary content, designing for disassembly, which I think this pavilion is, which is great to see. So a lot of work seems to be going in at the design stage, which is really great. There's maybe a cynical view that you can design for disassembly and then forget about it. And so you have to think about what's happening later down in the value chain. So that's one thing that we saw as a challenge to adapt. And here, given time, I'm not going to go into all of these, but we did a bit of research as well to see what are good examples where these circular approaches are happening across each stage of the value chain and also at each of the different levels. And the report, which I'll show a QR code at the end, has some case studies where we have some good examples of that happening. Maybe one which we'll come back to on plastics is around procurement and how you can embed circularity indicators into procurement processes. But I think we'll come back to that. And then finally, what I think is one of the main kind of value add from our report, or something that should hopefully be useful and we hope industry will take up, is basically a toolkit of indicators that can be used by industry to measure their circularity performance. And we did this at the 4 levels. And also, if you look in the report, we linked it to the value chain elements. So you can look in the report, you know which bit of the value chain you're in, and you can see what are the top recommended indicators that you can use. Maybe one thing to say here is there's just so many possible indicators, and you'll know that there's already different standards and like levels and different methods being used. So what the Commission really wanted us to do here was try and consolidate all of the different measurement techniques that are being used, all of the different indicators, and do a scoring system and discuss it with industry to come up with, if you just had 4 or 5 at each level, what would they be? And also to recommend units that would be the best units to use that ideally all industry is then harmonizing. So that's what we have. And if you look in the report, this is really just a high level infographic, but for each indicator, there's a page which gives a lot of detail on data that's needed and methodologies that exist in order to do the measurement. One thing that we also did was try to identify where you can aggregate data. So where data, for example, for one of the product and materials indicators can also then be used to aggregate into the building level, which I think, is a really important thing. So you're not collecting lots of different data that can't be harmonized together. And so finally, before I move to the next section, we also looked at drivers and barriers associated with measuring data to understand why the measurement level is so much lower than the activity that's reported. Not necessarily that surprising, but a lot of the drivers and barriers are related to data. So lack of data, lack of harmonization of data formats and methodologies. So one of our main recommendations to the Commission is to look at through different levers how we can facilitate easy data sharing. Obviously, the Commission's doing a lot there already. And then also some drivers around investment and finance and how we can help the circular transition in general and how that will lead to more investment in measurement and reporting. And then finally, just to pick out the importance of circularity performance targets. So if within a business you have a performance target related to circularity, and more than just the sustainability officer is responsible for the performance of that target, then you're more likely to measure it and report it. So I'll stop there. That's just a very quick overview of the study. And at the end, we'll have a QR code if you want to download, because it's very recently published. So thank you.
Thanks, Edie. So I'll dig a bit more into plastics into construction. And we've been doing a study indeed for the Plastics Europe, which is the federation of the plastics manufacturers. So I will be looking at the manufacturing stage. How can we make it more circular, but also for construction? What are the key levers to, at the end of life, make sure that plastics gets out of the system and have a second life, a third life, a circular life. So maybe just before we enter, also I'd like to set the scene a bit. So if you move to the first slide, that's just the current status of plastics in construction. So overall, in 2021, around 50 million tons of plastics were produced. Around 20%, like Indy said, is really dedicated to the construction and building industry. So the way we look at it is we look at different polymer types. So you see PVC, unsurprisingly, is one of the biggest polymer types you find into construction. It's found in pipes, window frames, door frames, flooring, etc., etc. Second biggest are the polyolefins, so low density and high density, especially sheets. You see a lot of materials also being used for insulation purposes. You see cable connectors, etc. Then polystyrene, again, isolation is a big there. And then polypropylene is especially also fittings and geotextiles. So that's the current state of the construction industry when it comes to the different plastics being used. If you move to the next slide, what our study was really about is making the plastics industry circular, net zero, and safe. So what I want to zoom in on today is really the circularity piece. So our strategic objective was making plastics circular, which means decoupling from using fossil-based fuels like naphtha into the manufacturing of plastics. What are the things we can replace it with? Those are on this graph. It's mainly mechanically recycled plastics. Like I see a very nice example of mechanically recycled plastics. Chemically recycled plastics, also plastics made from biomass, and then a very niche application, which is combining carbon capture and utilization and hydrogen. So you can also make plastics from that. So we defined a model saying how can we move between now and 2050 to include more circular feedstocks in the manufacturing process. And what we found is today we're about 85–90% fossil-based plastics. And what we are showing in our study is that a 65–70% increase is possible by 2050. So now that's mainly looking at upstream, so the manufacturing stage. What we also want to see is, on the next slides, is what about the construction industry? How can we move away from having waste that's not being used in anything productive to getting that back in the system and having a circular life cycle instead of a linear one. And so we've been focusing on especially two levers. So that's mechanically recycled plastics. So it's getting in buildings, collecting selectively plastics, most likely doing that from a really selection point of view, meaning all the same plastics are collected in different streams. And you see that this is the biggest lever with around 45% of the plastics being able to be mechanically recycled. So this is also what we call high quality plastics, meaning they're easy to recycle. Usually they're shredded, cleaned, and then used in other applications again. Now we also see that for different types of plastics, the mechanical route is just not possible. This means by legacy additives that are still in the buildings use their plastics and they stay there for 20 to 50 years. So also in 20 to 50 years, getting those plastics out of the buildings, you will see additives that are not used today and very hard to recycle. So that is where we propose chemical recycling, meaning you it's about depolymerization, gasification, and sometimes also pyrolysis. So it's really getting back to the virgin quality-like polymers. And this is a much heavier, also more energy intense process. So that's also why we want to only focus on very hard to recycle plastics. So this is all nice and well. I guess everybody agrees on moving towards more circularity on plastics, but also what is needed to get there. And so on the last slides, I also want to share a bit what are the pathways to get there. And these are asks that we will incorporate in our reports. I listed a few of them just as an illustration. But yeah, again, we have much more detail in the report that's to be published. So I guess three main buckets. First bucket is we need to be able to use plastic waste as a circular feedstock. That's really the important. So we need to source it, to extract it, not only from buildings, but from other places. So what do we need? Therefore, we need recycling facilities and recycling infrastructure. Currently, Europe does not have a lot of recycling infrastructure. That's why historically the recycling waste has been going to Asia, ending up being burnt in jungles and in those really nice beaches you've always see pictures of. So that's really a pity. So we need to being able to manage our own wastes in Europe ourselves. So that's the first thing. It's about investments. Second thing is we need to stop incineration and landfilling. Incineration is just burning plastics. It's always been branded as, okay, we recover energy from it. Basically, at the end of the day, it's also emitting CO2 into the atmosphere. And so that's just a waste, and we need to stop that. Landfilling, exactly the same. It's being captured in the ground, but it needs hundreds of years to decompose and also emit CO2 by being in the ground. So that's also something that we believe as Deloitte, but also the industry is asking for. Shipping of sorted waste, we see a lot of regulation prohibiting shipment of waste and also recycled feedstock through Europe. That needs to stop. We need to treat it as a primary material and not as waste streams. And then as well, that's also coming back to what Indy said. It's all about defining standards, defining what data needs to be captured. And that's also something that we see as a major ask to the policymaker, but also an ask to society. So that's really everything around treating plastic waste as a circular feedstock and using it. Second is increasing the demand. So you always have a supply-demand dynamic. We also need to be sure that plastic is being used in new products. So the first point there is mandatory recycled content levels. So I believe if we want to use plastics again in new materials, we need to have certain standards saying, okay, we need at least 20-50% recycled content in products that are being used. So that will incentivize demand, which on the other hand also will incentivize the collection and recycling of plastics. Also having evidence-based and plastic agnostic view on prevention. I think everybody agrees that single-use plastics is bad, but other plastics we cannot avoid, especially in buildings, insulation, thermal protection of buildings. We will not be able to do it without plastics. It's a very cost-efficient and easy material to use. So prevention needs to be, I see a pointing finger, I like it. So we need to be really careful and just not say, okay, all plastics are bad. No, it's about polymer types and it's about applications. So prevention also from an EU perspective needs to be really targeted and focused. And thirdly, citizen awareness. I think we see a lot of emotions or anger towards plastics. I'm in Brussels, we see a lot of demonstrations. It's also, I think, from a lack of understanding that plastics is part of the future, but it needs to be targeted in the right applications and also for the right polymers. So creating awareness, creating education is really something we strive for. And then the last bit, and that's especially from a plastics industry, a plastic manufacturing industry perspective, is getting funds. We've calculated in the model how much this transition to 85% fossil-based to 65% circular-based feedstock will cost. It's not in billions, it's not even in hundreds of billions, it's in trillions. So we will need, the industry will need to be funded or at least incentivized to go that route. And then I'm not speaking about getting to net zero, I'm only talking about circularity. So it's a huge investment, and putting pressure on the plastics manufacturing industry is very easy. But at the end of the day, it also means that Europe loses competitiveness towards other regions. And this means that I visited a plant in the Netherlands, and the person showing me some graphs said, okay, this is our pathway towards net zero towards 2050. And around 27, you see a huge drop in CO2. So yeah, we're consultants, we ask questions. So we were like, okay, what the hell happens in 27? And it says, okay, we're just going to close a cracker and we're going to build a new one in Saudi Arabia. So that's not the way to go. We want industry to stay in Europe, but we also need to be incentivized to stay in Europe, meaning getting funds, getting tax breaks or other policy measures. So these are the three big buckets that we will also explain in much more detail. I have about 10 to 15 minutes today. I'm sure if you read the report, you're, I think, one day in. So I won't get into that much detail, but it gives you a view on what's needed to get there. And that's what I really want to emphasize today. So I think that was it for me. One last slide, and that's also what Indy was sharing, was our both reports. So the report of Indy is being published. I think it's published 1 week or 2 weeks ago?
Yeah, a few days.
A few days, okay. The one we will be publishing will be in October. We're pushing a bit to shorten the deadline, but let's say end of the year, Q4 23, will be published for everyone to download and read. That was it from my end.
Thank you. So I take with me that you mentioned there was a measurement gap. Actually, there's a lot of things going on already in the industry, so that's nice to hear. But we also need to be able to measure it and document it and talk about it in an equal way. And then I also heard you said that there's also a lot of things going on in the design phase, and we have the architects. They are really engaged in the circularity and design for disassembly, but there is maybe an opportunity or a responsibility to also look further down the value chain and what will happen in the end of life of our buildings and our products. And I hear you say that there's a need for the infrastructure to take place in order to recycle the plastics. And we also need a more nuanced demand for circular plastics and the funding you mentioned. So I would like to ask you, in terms of the responsibility of also taking action further down the value chain, what can the industry do, the plastic industry and the manufacturers, what can they do?
To incentivize demand or to create awareness?
To increase circularity and actually taking action on this point.
Yeah, so I think one of the things we stress in our study is also to incentivize all of the manufacturers to collaborate with the value chain. So this means can be from projects, for instance, Operation Clean Sweep is about getting plastic pellets away from the environment. That's something that you need to do with your value chain, because as soon as the pellets leave your production plants, basically it's not your responsibility anymore as a plastic producer. So you need to put pressure or ask to your value chain, okay, guys, please take care of this, and these are the measures you can take. And then from a data perspective, I think what we've seen in Europe being pushed more and more is digital product passports, and it's being developed for a certain number of applications. So this is really getting data each step of the way on the value chain, and we're doing, the industry is doing really dedicated pilots in certain very dedicated applications. But I think as of the coming years, as of 2030, this should be generalized, meaning that every actor in the value chain has access to data, but also needs to feed with their own data what happens at their gates. So these are data and data measures, but also project measures that we push towards the manufacturers, saying you have a responsibility. It's not only your fight to fight. So please collaborate with the whole ecosystem, the whole value chain.
And maybe just to complement on the building level, we're seeing the circular economy also means a move away from building new buildings, like demolishing a building and building a new one, and towards renovation. And EU public policy is really supporting that as well. And I guess for architects and designers, that means that you have to engage with the demolition phase or the end of life phase of a building and renovate and think about design in a different way, which might mean that designing a whole building for reuse should become a lot less common, and a lot more common to look at an existing building and see how you can renovate. So that's part of the policy direction. Will kind of force the value chain to move in that way.
Okay, thank you. Are there any questions?
Yeah, so what does the... Oh, okay. Yeah, one question. Oops. You said you work together with the EU Commission.
Yeah.
So what does the Commission do with the study results exactly? Do you have any, can you foresee or tell us a little bit what's going to happen in the future because of some of the results? Or
Yeah, it's an interesting question, because often the work that we do with the Commission will be directly to feed into some legislation. But actually the Commission wanted to do this study because there's lots of legislation coming down the line, which is requiring industry to do lots of reporting, including construction product regulation, the EU taxonomy. There's existing reporting on carbon measures as well. And so this was a study a bit separate from the legislation for them to try and sort through the mess and think, how can we streamline some of these processes? How can we maybe bring in fewer requirements, but also incentivize industry to move in the right way? And that's as well why we looked at drivers and barriers and a toolkit that industry can use itself without having new legislation that requires industry to do that. So it's a bit of a fluffy answer, but it's not specifically for like lots of new legislation to come out. It's more to help the Commission to streamline and to support industry. So, but we'll see exactly what they do with it.
Any other questions? Okay, thank you so much. And just a round of applause. And then we will make room for the panel up here. So we'll just organize. And I think we need an extra chair.
That's fine.
Thank you.
Are you ready?
Should we make a sound test or we'll start out? Okay, we'll take it as I introduce the panel. Yes, okay. Welcome to the panel. First off, we have the practitioner, as I call you today, Nana Gudmansen, market manager in Swego. Then we have the scientist, who is Stefan Petersen, professor at the Civil and Architectural Engineering of Aarhus University. Then we have the one representing the manufacturers of EPS, Kristen Heide Andersen, Vice President of the European Manufacturers of Expanded Polystyrene. And then, as we already know, we have Indy, you just switched, yes, Indy there, and Mikael from Deloitte. And we'll have a more in-depth presentation of you in just a moment. But before we do that, I would like to hear who are we gathered here today. So in the audience, do we have any architects present? We have one. Do we have any manufacturers? And are you manufacturing something with plastics? All of you? No? Okay. Do we have any engineers? Yeah. Do we have some building clients, public or private? No? Someone within policy? Yeah. And maybe have we covered everyone now, or is someone? Lobbying. Okay. Yes. So, and no NGOs? Oh, I think we covered. Okay, so it's just nice to know who's in the audience, and only one architect, even though we are as a part of the architectural congress. So, but good to have you here. Okay, so now I'll give you each one of you the opportunity to introduce yourself, and I would like you to also tell how are you currently working on measuring sustainability, and then if I could ask you to share maybe a surprising fun fact on data about yourself. And we'll start off with you, Memme.
Thank you. Well, as you Simone presented, I'm from Sweden. I have a background in civil engineering, like the other people here on the panel. And one of the main things that we actually work with when we talk about measuring sustainability, there's two factors. One of the first ones is, of course, life cycle analysis, LCAs. We can't get around it. It's requirement now, building regulation requirements, and therefore it is a main focus that we are working on in all new construction, as it only applies right now to new construction, the regulations. And another part where we measure sustainability is looking at certifications such as DGNB. It used to be called sustainability certification. Of course, it's not allowed to be called that any longer. But that focuses on a more all-round focus on sustainability. So not just looking at CO2 footprint, but looking at different aspects, looking at the social, economic, and the environmental impact in regards to sustainability, as most of you probably know. And a small fun fact, I started specializing in sustainability, focusing on the UN 17 Sustainable Development Goals, actually, and trying to turn that into a building and construction context, basically translating it. And the main issue we had was making it measurable. It's very difficult to translate these very universal goals, which are supposed to be measured on an international level, than to turn it into a building-specific context. So we would very often rely on the more common practices like DGNB or LCA.
Thank you. Then we continue to you, Stefan.
Thank you very much. Stefan Petersen, professor at Aarhus University. Been doing that for many years. Before that, I've also 10 years of experience from the construction industry. So I've also done my share of building designs and other stuff. I do a lot of research. I do a lot of different types of research. The one that would be relevant to mention here is that I was co-authoring the first scientific paper in the world that benchmarked the environmental impact of a building up against the planetary boundaries. And ever since we did that in 2016, that has really become a trend, not only in science, but also in the industry. So we're kind of proud of that. And we have a lot of students still looking into to that aspect, and also trying to push the agenda a little bit. So I think that would be the short introduction that is relevant here. And a small fun fact for my part would be that I don't care about legislations and DGNB and stuff like that. I care about the truth. And that's something else.
Thank you. And then up to you.
Hi, my name is Christian Heide Andersen, and I'm the vice president of UMAPS, which is the manufacturers of expanded polystyrene. It also represents the raw material suppliers, the machine producers, and not at least the recyclers of expanded polystyrene. It's a material which is widely used for packaging and for insulation, as we just heard. And what I do in regards to circularity is I work a lot on ensuring that more EPS packaging is recycled, because we need EPS packaging recycled both for packaging and for use in recycled content in construction. And actually, we found out via various searches and have been recognized by the Ellen MacArthur Foundation that EPS packaging is the second most recycled packaging polymer globally, being recycled at scale in practice in 38 countries in across 4 continents for more than 4.2 billion people. That's quite impressive for a packaging that some say cannot be recycled. And you might think that this would be my fun fact, but it's not, because I care about the truth just as you do. My fun fact would be that I run on average 9.94 kilometers when I referee a soccer match.
Wow.
Good on you. Good on you.
Thank you. And Indy?
So I won't introduce myself
No,
again to
but
save
yeah.
some time, but I'll do another running related fun fact, which is that I've done 8 half marathons in the last 8 years. I was supposed to do one in Copenhagen in 2020, but maybe I'll do it next year. It got cancelled.
And do you have a fun fact to share?
Yes, so I have 2 facts. So one about myself and one about the plastics industry. So I spent 352 days traveling the world between 2 jobs. So I started out at EY, one of my current competitors, and then decided to take a 1-year break to travel the world. And that's actually how I get really into plastics. I'm a certified diver, so I'm a body advanced diver, and plastics is also everywhere in the ocean. And that's also what gave me a push when I joined consulting to focus on sustainability, to focus on circularity, to focus on circular plastics. And I'm really happy that I was able to pursue that route thanks to something that happened in my life a bit randomly. So that's the first fact. The second fact is really about plastics themselves. So about 50 million tons of plastics are produced every year, and about 30 million tons are getting into the post-consumer waste collection schemes. So this means that 20 million tons, we just don't know what happens with them. So around half of it is really part of exports or the new stock. In buildings, we do contain plastics for a long period of time, but between 8 to 50 million tons of plastic, we just don't know what happens. So it also shows that, yes, we care about the truth, but the truth, we just have some things that we don't know yet. So it also makes it very interesting and challenging to go to pursue that and get more clarity on some of the black boxes within our industry. So it's not really a fun fact, it's rather quite scary, but it also makes it interesting and challenging to go and further knowledge base on plastics globally.
Thank you. And so I will structure the panel debate in 2 rounds. The first one will focus on data quality and also what I call pragmatism in terms of data pragmatism. And then the second round will be on absolute sustainability and discussing the market readiness of this. But feel free to raise your hand if you have questions during the panel, and I'll take them as they come and arise. So first off, I would like to start to ask you, Stefan, how can measuring, for example, CO2 emission help us reach the targets of absolute sustainability? Is there a risk of this measuring that it just becomes a documentation exercise? Will it actually change?
That's a super good question and a really complex one, and maybe also invalid one, because we are basically not supposed to emit any CO2 anymore. On the contrary, we are supposed to pull it out of the atmosphere, at least if we don't want to live with the risk of catastrophic consequences of our lifestyle. But that's our decision. So what we are doing now is that we live with these risks. And the question is how long we want to live with these risks. So we can set up a system, yet another human system, like the economy, that thinks it rules the world, where we talk about that we have a certain quota of CO2 to emit, and then everything will be fine. It's not like that at all. If we stop all CO2 emission today and leave the planet alone, it will take at least 200 years for it to generate to a level where we could say that now we live again in a safe zone where we could emit some CO2. So that's the challenge we're looking into, and we are talking about a relative reduction of, marginals. That's my big concern in this discourse about are we allowed to emit CO2? Do we have to make buildings or not, or retrofit them? And the talk about absolute sustainability, which is a weird concept, even though I have promoted it a lot, because we are in the situation as we is. So that would be my complex answer to a complex question.
And on that note, no, we'll try to dive into this, and I know it's really difficult, and there's sometimes you can lose hope, but I also think that we also need hope, and of course we need to understand the reality that it's important to act today and not tomorrow. But I'll pass on to you, Nana, because I understand what you're saying, Stefan, but we also live in a pragmatic world, and we have to go on with our life and everything tomorrow as well. So how do we apply a pragmatic approach in the early phases of a building design? Because when you're talking about all these nuances within plastic, there are so many different material choices you have to make. So how do you do that when, for example, you're conducting these variation studies? So it doesn't become too time consuming, because I assume the building clients, they won't want to pay for these big analysis in these early phases. So how do you do that in a pragmatic way?
It's not quite fair to ask me to follow that, because I am in the part of the industry where it's already been decided that we are going to build or we're going to renovate this building. So the case of not emitting any CO2, that's not the case. We can't do that. That's not possible. But what we've been doing for several years when we talk about looking into variation studies is always asking the client to look at the areas where we can make the most impact. Where is the most possible minimization of CO2 possible? Where is it we can actually have the most potential? And that has been for several years, that's been looking at the structural elements, looking at the concrete, looking at the steel construction. Are we looking into wood? The building envelopes is next. Looking at then the surfaces of the material. So basically starting at the large scale and then going down. And throughout several years, we've gained a lot of data on these elements. So we are getting better at being able to advise our clients up front at an earlier stage, saying what elements are we able to minimize CO2 without having to do too many variations in order to go further. Because eventually we are going to go towards not emitting too much CO2. We probably won't be able to see, say, zero emission. We will have to look at all aspects. So the industry is in a constant development right now, where we are starting with some of the larger scales, looking at how the most potential we can do, and then going further down into more detailed level. So that's also a very broad answer, to be honest, because it is a very changing stage at the moment. We don't quite know where we're going, but we are learning a lot while we're going ahead.
Yeah.
And that's why we have, as a company, we have made a database of all our LCAs to show basically upfront what is our baseline, where do we see as the main contributors to CO2 emissions when you're looking at a building? What part of the structure is it that's the main part?
And just to those examples, are they based on generic product data, or are they based on specific product data? Because I would assume that there's also maybe a part of the question, the answer, the dilemma. When do you use the generic data and when do you use the specific?
So early stages, if we're looking into what type of structural principle you want to use, if we're talking concrete or wood, we would look at generic data in most cases, because we are not that far ahead, we will be able to say product specific. But if we, for example, are talking about a building envelope, or we're talking about what type of tile we're going to use, then we would use the product specific. And the database that we have published is both generic and product specific data.
And you're welcome also in the panel to raise your hand if you have something to comment on. Yeah, okay.
A question to my fellow panelists here. How do you deal with the operation phase? How do you calculate that?
So the way we do it now is very standardized. You use the energy framework.
Is that a true calculation of
Nope.
the actual CO2 emission in the operation phase?
Nope, it is not. That is the way we've standardized it so far, in order to be able to represent the same, to be able to compare apples and apples. Because we can't at the moment right now, we can't say the specific amount of energy that the building is going to use. We can only do that on the back front.
No. We can estimate much better the actual energy consumption of what would happen in reality right now if we want to, with some degree of uncertainty like there is on all other kinds of data. But we can do much better than what we are doing today. And I think that's a problem, that we're not using the knowledge that we have had for decades to actually do change.
Which is fair enough, which is the part that we also need then to improve on. But my side of the industry is I have to work with the standardized method in order to basically apply the Danish building code.
Sure. But we risk that we make some wrong decision if we believe that the operation phase is lower than it actually is. Then we might invest in materials or underinvest in materials in a life cycle perspective. I think that's a huge problem that we should deal with right now because we are able to do it. Maybe it's not our industry partners that are conducting these things, but then in the other part of the value chain that makes these decisions on what we are supposed to do, they can make much better regulation, much better tools, much better, much more precise evaluations of what's going on, and then push that to the industry and say, this is the method, and it's much more precise, and it's much better, and we can make more qualified decisions on what to do. I think it's a big problem that we're not doing that.
And could you give a specific example on where do we have these challenges on calculating on the operation phase?
Well, the operation phase is the energy consumption for heating, cooling, and lighting and ventilation, and it's based on a calculation that is oversimplified to a degree where it's not really a good way of representing the environmental impact of that consumption. And we have tools, we have methods, we have data to do better, but we have decided not to do it. I don't know why. But it's not a criticism of over here, it's other places
on the
in
regulation
the
side.
Yeah, or whoever is dealing with these issues, because they are not doing it based on knowledge, that's for sure.
We also have to remember one part, that this has only been regulated, calculating CO2 on buildings, has only been regulated as of 1st of January. So it is still a very new method. It's definitely flawed. I do not disagree with that. But it is also a thing that it needs to develop. We don't have the perfect method yet. We probably never will. But we are going to get better at it. And in order to get better, we have to start somewhere. We're not going to build a Rolls Royce today. We have to maybe start with a skateboard. And that's pretty much where we are.
I was just hoping we would start with the current knowledge and not 20-year-old knowledge, but that's just my thinking.
Yeah. The next thing you could think about is maybe we need to save CO2 here now. And the first part we can save CO2 on, that is the construction phase.
Then we shouldn't build new.
Very true. But it is still a way to reduce, yes.
And just to remember the European context, then in Denmark, it was as of the beginning of this year, we had the regulation on the climate footprint of buildings, and we are one of the front-running countries in Europe to have this type of legislation. So yes, it's new in Denmark, but also in a European context.
But it's
you have
yes, and that's because what you mentioned reminded me of a McKinsey study that was published last year. What McKinsey did is they compared plastics to a number of other applications, and they looked at what is the best alternative, which has the lowest impact. They looked at both the production phase and the use phase. And one of the funny things is that in 13 out of 14, plastics actually had the lowest climate impact compared to the best alternative. And for one of these applications, it was insulation. And what McKinsey had looked at was for insulation, they found that the production or the construction phase using a mineral wool would be better. It had a lower climate impact on the construction phase. However, when you're compared over the lifespan of the construction, due to heating, due to how you test insulation materials, that how effective they are, we test that at a degree of 10 degrees, but some materials become more insulating or better insulating at lower degrees. They actually found that comparing the plastic insulation with the mineral wool insulation, the plastic insulation had an 80% better climate impact over the lifetime of the building. And of course, this is a US study and you can't compare it directly, but looking at the lifespan, looking at the actual use phase, looking at the savings of or prevention of food waste, taking that into account when you're doing LCA studies, when you're doing EPDs, is essential if we want to do climate prevention. We can't just look at one phase and then ignore why we're making the product. We're doing it to live in. and then saying, okay, then we'll look at what happens when we demolish it. For a house, that's ignoring 50 years of when the house is there. And that's why I think it's very important to not just look at A1 through A3 on an EPD, and then maybe D, when you're ignoring all of the key phase of why we're actually building or renovating the house. So I would fully agree, we cannot ignore use, and we have to have a proper definition of a functional unit. That's not same statistical use or in insulation properties. It has to look into what happens with water and all kinds of other applications. And this is what, again, McKinsey did. And again, it's a US study, but it's still relevant because you came out with a completely different picture when you looked at the use phase. So I would agree, we need to look beyond just construction.
I can recognize some of the things that you say there from a Danish study we did a few years back in relation to retrofitting existing buildings, where we also looked at the life cycle of various different insulation materials for retrofitting purposes. And the polymer-based insulation materials also ended out as being ranked the highest, looking at the full life cycle of things, depending on the thickness of it and blah, blah, blah. But there were some scenarios where it ended out on the top. I think 80% sounds like a lot, but there's scenarios where it definitely ends out on the top for the retrofit purpose in a Danish context, just to add a note to that. And then it's always a discussion about, phases. And there's a tendency to think about A1 to A3, looking at that. That's a life cycle analysis. That's the new, we have to look at that data. But it is with all the phases, and we should look across all the phases. That's one thing. But there's also the time. When do you emit this CO2? And that's something that we cannot overlook anymore as well. There needs to be a time component to the emission over time as well, because we also know that we are transitioning towards more renewable energy production for the operation phase and so on. So it is a really difficult to look ahead in time, and it's more easy to say what can we avoid right now, because the uncertainty increases over time. And that's another thing, all the uncertainty that we have in these calculations. Why don't we account for them? It's unbelievable to see the bottom line, 52.32 CO2. It's like, no, it's not going to happen. It has uncertainty.
Thank you. And just to move a bit on in the discussions, I would like to ask you, Mikael, what are the available data and what is the implementation gap in terms of measuring circularity in plastics?
So can you repeat that, please?
Yeah. So the available, I would like to, if you could talk about what are the available data and what is the implementation gap in terms of measuring on the sustainability of plastics?
Yeah, so that refers back to the comment I made earlier on the 50 billion ton of plastics and the gap that we have on the end of life phase. I think this is really the biggest issue that we have at this moment in time, is really measuring where does the gap come from, what's the reason for it. And it also comes back to a better understanding and a better measurement, and that's exactly what's in these studies about, of how much is used into the different applications, the construction, but also other applications. And at the end of life, what happens with plastics and other materials? Are they getting recycled? Do they get shipped to the other side of the world? Do they end up in the environment? And that's something that we need to test more and more. And I don't have a straight answer on, okay, how do we need to measure that? I personally am a big believer in EPR schemes, so extended producer responsibility schemes, and gathering the data along the value chain, meaning as soon as a brand owner puts plastics on the market or other materials on the market, they need to measure that and they need to communicate it to a national EPR scheme. And that will help us get a better vision of the upstream, not the downstream. I think this is where the issues lie, because a lot of plastics gets mixed with organic material. It gets weighted. There's a lot of uncertainty, but getting more recycling facilities and getting more technology available in the end of life phase will definitely help us get a better grasp on where does these 8 to 50 million tons go? How do they disappear? and also getting shipments out of Europe being really closed. I think that's the way to go for the future. So that's short answer to also a very complex question.
Yeah. It's definitely.
I think you're onto something here, because the D phase is happening now with plastic. We don't have to wait 50 years to think about what's happening with D. It's happening now. It's been happening for so many years. So there's a lot of plastic out there in the ecosystem. How to get that back in the loop, that's the challenge.
Agreed. Yeah.
And Kristen, you have already touched upon it, but in terms of discussing this, we need to compare the materials in the same way, and we need to have a functional unit. But just would you like to expand a bit? What are the challenges of spreading the awareness of the environmental values of each of the manufacturers' different materials?
Well, I think, at least in Denmark, we came at one point from an environmental discussion where we looked at insulation for 1 kilo. What's the CO2 impact of 1 kilo of EPS compared to 1 kilo of mineral wool, or 1 cubic meter, which is sort of pointless, because you're comparing apples with concrete walls, and if you're doing that, then you don't make informed choices. You make blind choices. What we need to do is go beyond that. And now we're getting closer to something where we're saying, let's look at 1 square meter of insulation and see how well does that insulate. So we should compare the same insulating property. But that's not enough, because insulation is just part of the building design. We need to look at the house, or at the wall, or at the foundation, or at the roofing system, because using one type of insulation compared to another has different properties. What's the compression strength? What's the lifespan? How does it act at minus 30 degrees? How does it act at 40 degrees? We have to look at all of these factors. What's the fire resistance? We know that plastic is combustible compared to other materials. We recognize that, but we are still capable of building fully fire-safe constructions with plastics insulation, because we're doing other stuff. And it's about looking at the entire construction to do that. And then we also have to compare prices, because plastic is typically very, very cheap. It's very cost efficient. And maybe by using a polymer insulation that's cost efficient, you can do other stuff to prevent CO2 emissions at other phases, or you can use other measures to increase fire safety. You have to look at the entire construction and not just look at one material, or that would be the same thing essentially as saying, oh, we have to define what material each screw in the house should be built up based on. That's the key thing in climate prevention. Is it a 2-inch screw or a 5-inch screw? That sounds ridiculous, looking at only the insulation material and not looking at the full design and the full lifespan of this of the house or factory or whatever it is the sure way to do the wrong thing. Or if you do the right thing, then it's a lucky chance.
And I think before taking you, Stefan, I would like to direct the question further onto you, Nana, because I think I understand from a manufacturer or producer's point of view that you need to understand the complexity of when is the material used. But Nana, are you actually doing that already? Or
We are.
Yeah. And could you just elaborate that? Is this actually a challenge, or would you reply back?
It has been a challenge for quite a few years. We talked about it just before the panel. That we used to have this pyramid for materials in Denmark that was created, and it compared them on not equal terms materials. So basically, the only material you could ever use was wood, which is not telling the entire story. So what we do at the moment is, our job as consultants is to give the entire perspective give all the elements, talking about what is the positives, what are the negatives of using different materials, and then we technically only can consult our clients on what is the best solution, or what is then, of course, the negative side of choosing another solution. And that is just to give them an informed decision.
Yeah. And do you have the necessary data and knowledge from the manufacturers to do that?
On many of the elements, yes, we do, especially when we talk about insulation materials. We do.
Okay. Yeah.
They can follow up. That's fine.
Okay.
Maybe it's a follow-up to this.
Yeah.
It's a follow-up, but that's just because I was in a discussion, and what you were saying just reminded me. We have there are clients that are saying we want a plastic-free so-and-so. We've seen this in packaging. We want a plastic-free packaging. So then you switch to a cup, which is plastic coated, but consumers thinks it's plastic free. Now we're also seeing this a little bit in construction. We should move away from plastics. So we're using to mixed materials. So we might have mineral wool with plastic binders. And some studies have actually found that there's more fire energy in the mineral wool. So if you have a full combustion of the building, that's more dangerous. But that's a different topic, and we will have that later. I can see our speaker from the 4 o'clock panel will be here. He's an expert on that. I'm not. But we have to also look at, to the extent it's possible, at materials that are easier to recycle because they're monomaterials compared to multi-materials. And for a large number of cases, plastics is just easier to recycle once we have it collected right.
Stefan, did you have a comment?
Yeah, well, that was a comment on this question you raised about functional unit and stuff like that, and also a comment to what was being said here, that talking functional unit for buildings is a weird thing, especially when we think about this material pyramid, which, by the way, I tried to tell Pelle is all wrong, but they pushed it anyway, and it's very, very popular, but it's not helping. But we are kind of lucky, at least in a Danish context now, that we have a bottom line to look at instead of. So it is the bottom line. It is the CO2 emission on the bottom line that should be optimized. And then we can start to look at materials with all its properties in the A1 to 3, but also the properties for heat insulation in the operation phase. And we can look at the bottom line when it's the optimum. One of the problems we have there in the Danish context as well, when we talk about retrofit, which is going to be a big thing, right, guys? Yeah, it's that we have U value requirements. So you have to fulfill a certain U value in your retrofit situation. But if you do that with any kind of material, you will end up with a different bottom line in terms of CO2. For some materials, you should stop earlier, and for others, you should go further to get the lowest CO2 on the bottom line, which gives different U values. So we also need to move away from that way of thinking and look at the CO2 bottom line for everything that we do, and then forget about functional units. Doesn't matter in this case. It's all on the bottom line. That's why I think we should be going with this.
Okay. And just to put another perspective, I would like to ask you, Indy, how, because, or maybe it's not a challenge. I've heard in other corners of the industry that there is still a data gap and that there's still a lot of missing data on materials. But maybe it's not correct. So please correct me if I'm wrong, because otherwise I would like to ask, how can we, from a policy perspective, encourage industry to keep developing EPDs so that we have the right data and a high quality of data available?
Yeah, of course, and I can maybe answer also more broadly with measures like that and how policymakers can increase the uptake. So I guess like the most simple measure is to make something mandatory. It's a bit of a blunt tool, but it's got to be used carefully because there's already a lot of mandatory reporting. There's more coming, and you don't solve the data gap sometimes with that. So you can make something mandatory, but if there's still a data gap and there isn't a way to facilitate it, that can also have harmful impacts. So then the other measure, there's something we looked at in our report, is more around facilitation and how governments and industry can help to facilitate getting better data and sharing it. So different measures here. So some around standardization, and there's obviously a debate that we got into around simplification versus accuracy, and whether you have, sometimes at the EU level, you have the lowest common denominator that at least everybody can follow, but you need to allow space for industry to improve upon that. But with EPDs, you can see that ISO standards, I think, are helpful, at least in giving a global signal in the importance of EPDs, and also providing for interoperability where you have standard templates and methodologies to follow. So that's something with industry facilitation. At the public policy level, there's also the digital transition is supporting data sharing with things like digital product passports. We mentioned supply chain due diligence and extended producers' responsibility. So trying to facilitate and encourage or even mandate supply chain to share data. And maybe the final thing is money. And the EU does some interesting things here. So if you look at the taxonomy regulation, you can then have grants and funding that's connected to having better metrics and circularity. So linking funding applications to things like having an EPD, or linking public procurement to having EPDs, I think can incentivize. But I'm sure panel members might have other perspectives as well.
Any comments on the?
We're experiencing right now at the moment is a race for most suppliers to actually have and distributors to have an EPD. We actually do perform EPDs as well for clients, and we see that for them it's basically a parameter to be in the game. If you want to be a part of it, you have to have an EPD because it just basically makes you more attractive. We can see with most calculation for most materials that if you compare generic to a product specific, not in all scenarios, but in most cases, product specific will have a lower CO2 emission. So therefore, there just is a natural incentivization to actually have EPDs and to use them. And therefore, you would, in most cases, also prefer to buy a product, especially if it's one of the materials that you use a lot in your building that actually has a product specific EPD.
And what about the quality of the EPDs? Are they comparable, and or do you have to?
They are definitely not comparable. So first of all, we have two different. There's an old method and then there's a new method. And then there's also, when you talk about an EPD, you look at the values. Do you look at the functional one or do you look at the technical? So it's not comparable at all. And but that is a little bit of the Wild West at the moment.
Okay, you raise it.
Yes, that's you're saying that they're not comparable. I would agree. To some extent, sometimes there's also a question about what database you choose from. That can make changes. Then it's also about some companies are very large and are experts in EPDs. Others are smaller and may not have the same expertise. And sometimes you can move a little bit about where you put certain aspects in an EPD, and that can impact not the total, but can in fact phase 1 or phase 2 or phase 3 or so. Say for instance, you take a wooden pallet and place it in phase 1 through A1 through A3. You reduce the climate impact of that material in the construction phase, but then you incinerate the wooden pallet and you have no impact. But adding a wooden pallet is suddenly something that impacts the CO2 impact of the building. If you've used another pallet or another material, that will be different. Say you used or wrap your material in a bio-based plastic film, that would have a different impact. That's an issue where larger companies may have better expertise in knowing the math. And then it's also, then a question is, how good are you at the math and the dialogue with the consultants that then verify the EPD? There is, I'm fairly certain, a bias towards very, very large companies because they can have 30 or 40 EPD experts on the payroll, compared to smaller companies that could then just try to do it as best they can and the way it was intended to do. So EPDs right now are, I think Wild West is a little bit of a nice way to describe it. Middle Ages, we're getting there. Ice Ages and cavemen, we're certainly at a better picture.
Do you have a comment from a science perspective on this? Or?
Well, with the EPDs, I mean, not really. I mean, that's something that we need to figure out. It's again a bottom line issue for me when we talk about these things. But of course, it's nice to be able to compare different materials easily and stuff like that. So whatever we can do to standardize that, I guess it will help. Yeah.
Okay. Are there any questions on the topic of the data quality and data pragmatism? No? Then we'll continue on to the next phase of the panel discussion. And I would like to ask you, Stefan, what is the need for innovation from the manufacturers to support a construction sector that's operating within the planetary boundaries?
Wow.
If you fix that,
Yeah. I won't say that here. I should patent pending that or something like that. That's going to be a challenge. I mean, it goes hand in hand with many things. We have a raw material crisis that we need to deal with in parallel of transforming our energy production system into renewable energies. How do we make carbon sinks? I think it's a big question. How do we basically suck carbon out of the atmosphere and store it, other than just having the nature do it? So there's so many things to deal with, and how the construction material industry tap into that it's really difficult. I guess you have to start by looking at the whole value chain and say, as you said, where can we get the most out of it? You know, where are the savings potential high, and where can we get the most out of it? That kind of analysis, but I actually don't have an answer like that.
No. Okay.
I was taking notes. I was going to get rich.
Exactly.
Because I assume there is need for innovation, because we really need to reduce the footprint of the construction industry.
As I said in my introduction, we basically should just stop, right? And then figure out how to pull something out of the atmosphere so we can get back to a safe operating space. But you know, that's, yeah, stop doing anything. You know, that's not as you said, no, we have to move on from here. But that's basically what we need to have.
Yeah. Okay, so you would rather, like, from maybe policy side, you would like to see a no stop, full stop in building.
That would be interesting, and then have a look at the existing that we already have. I mean, when you look at the square meters we build and spend, it's exponentially increasing in the amount of square meter per person within a few decades, because we are so rich, we don't know where to put our money. We build more. So there's something wrong, you know, and stopping that and figuring out what to do, what we already have, is the solution. But I'm not sure we can go there based on the economic paradigm that we have today. It's also a big problem.
Yeah, because I would assume that there might be a need to innovate solutions that makes it easier and more economic, sustainable to do these renovations and be much better at that.
Oh yes, for sure. And then remember the building physics, so you don't screw up the old stuff. That's also a challenge, and something to do with education of both craftsmen and the whole value chain in general.
Yeah, okay. Indeed.
So I agree completely from an environmental perspective, but I'm wondering how you then consider housing crises that exist with growing populations. Maybe we shouldn't have growing populations, but we do in some urban centres, where you have maybe temporary accommodation that's not fit for purpose. So there's long-term solutions there, but there's a real urgency in some urban places to have better housing. So how you consider that with the full stop policy?
I don't know. I mean, if we look at it worldwide, it might be a problem, but in a rich country like Denmark, the square meter per person is super high. So I'm sure we can fit more people into existing stuff. But it might not be like that in other parts of the world, and then it becomes a true challenge, how to deal with that and how to make the world more sustainable in those places. I mean, somewhere they already live and spend like 3 families in the same home, sleeping at different times to get things going, right? So the challenge is, of course, different depending on where you are in the world. But in a rich country like Denmark, we have to stop and use what we have. I think so.
And just to continue with you, Indy, often we talk about the environmental issues as something where we need to subtract and we need to do less, as I hear. But I also think and hope that it's also a possibility of creating some new opportunities and maybe increasing the quality of life. So the question to you is, how do we utilize the sustainable transition and circularity as an opportunity for maybe job creation or innovation?
Yeah, so interesting question. I think, so I guess at a core level, if we look at the sectors we have, some things will stop and some things will start or increase and decrease. So hopefully seeing a decrease in the landfill sector, but then an increase in processing to reuse and remanufacture. So leading to different, not necessarily more jobs, but different jobs and a shift there. But then, as you mentioned, the need to innovate will lead to more jobs. So innovation in the types of products we use, but also if we're talking about operations, thinking about society and how it operates and how we can change behaviors. So producers having to think about that, but also policymakers, plenty of work for consultants, I guess. But really rethinking the way that we operate in society needs a lot of brain power, and that will lead to jobs and hopefully value creation. Maybe one side point there is that a circular economy is about retaining value and not wasting value. So that should support the economy and not reduce it. It should be a positive economic story. Yeah, maybe, and then I definitely let you come in. Just around innovation, because we did a different project which was looking at education for innovation. And I think their universities and schools have a really important role to engage young people and to think more creatively about university courses. So engaging with industry, looking at internships and secondments where you can get more up-to-date experience that's not based on maybe old curricula and old ways of seeing the world. So that's an innovation that should take place. And then finally, governments, as we've mentioned, policy can support the transition and can encourage the move in those directions, and can give businesses certainty that if they start a really innovative startup, there's a future, and because the transition really is happening. And maybe at the moment, there's a lot of talking about sustainability, but people wonder if we really will reach climate neutrality in 2050. So giving more confidence to that direction also supports business.
We will not reach climate neutrality by that time, that's for sure. It just popped into my head. It's also, you showed something about circularity and stuff like that. I guess that's a great concept, but does it work without coupling it to a concept like degrowth or something like that? Because if we just continue to grow just using circularity, would that fit anywhere?
I just come in. That's a super interesting conversation, and that's something we had with the industry.
Yeah.
So we told plastic producers, okay, what are your expectations in terms of volume towards 2050?
Yeah.
And so all of them, let's say, okay, in 30 years, let's say 1% growth each year.
Yeah.
And we just said, like, guys, this is just totally unrealistic.
Yes.
So we did tell them, if you have a zero growth towards 2050, that's a success. And that's also how we looked at our model. We started with a 30% growth towards 2050.
Yes.
And we just said, guys, from a policy perspective, it's totally unrealistic.
It is.
So let's talk about not degrowth, but at least stability till 2050. And that's also how we readjusted our model, incorporating reuse substitution into the equation, saying this will actually level up volumes towards 2050, and you should be grateful. it stays stable towards 2050. We believe into a slight decrease, especially on very specific applications, packaging being one of the biggest ones. It's 40% of the current production in Europe at this moment. We don't believe it's going to be 40% in 2050. At least not single-use packaging, maybe reusable packaging is going to be a part of the equation. But we do believe that a stable or zero growth is the way to go for the plastics industry at this stage. And we convinced the biggest players, the biggest plastic producers, that's the way to go. So already having that perspective and having CEOs and VPs saying, I think you as a consultant with an outside view, that's the right way to go, that's already a big achievement on our end. So I agree with that.
Mm-hmm. Really interesting to learn. Kristen?
Yes, I'm just wondering to that question. Is your question or is your recommendation of zero growth limited to the plastics industry or to the economy as such? Because to me, and then going back to the McKinsey study, we should move to the materials with the lowest climate impact. So saying, oh, we don't want this, or we don't want that, we don't want concrete, or we don't want plastics. It should be, we have some objectives to achieve, which is climate neutrality or zero growth, or that's a policy discussion. I can have a personal preference for what I think should be the policy preference, but that's not my role here. But a recommendation to avoid a given material or another given material without looking at the overall impact could lead to a alternative crisis. We're talking a lot about plastic. You're talking about plastic packaging. The alternative to plastic packaging could be cardboard. Cardboard requires wood fibers. Wood fibers requires water and quite an abundance of land. Now, there are several wars being fought over water. Clean water is a very, very scarce resource. Planting wood fibers in Sahara Desert seems like very uneconomical and very unlikely. Is that the right solution? I don't know. Maybe there's somebody that has the invention, but we should not look at what is the material. We should set policy targets that says a packaging should do this CO2-wise, or that CO2-wise, or a building should do this CO2-wise, or this climate-wise. Looking at only the material, then you go to, oh, we should avoid this polymer. And what we saw from the Single-Use Plastics Directive is we banned polymers for certain applications that have never existed. That's a brilliant policy initiative. We also banned some polymers, EPS being one, for cups, which came out later, actually increased the marine litter because the alternatives to the EPS cups weigh more, or you double cup. So if you actually increased marine pollution by a ban, that would have been better served by giving it the same regulation. So when we do...
So your question is...
No. My question is, are you only asking, are you only saying there should be zero growth in plastics, or is it across the board?
Yep, and that's a good question, and maybe giving a bit of nuance there. So the zero growth means that certain application will decrease, and we will sell less plastics in those applications. And other applications will increase. For instance, the example we always take is single-use packaging versus plastics in electric cars. We know that we need to electrify our transportation. The most lightweight and efficient material and affordable material is plastics. So we see an increase of intake of plastics into the automotive industry, and that's something we push. On the other hand, agree that single-use packaging is maybe a bit too broad to just bash on it. But on the other hand, we also see, and the expectations of the producers are that they will cater less to the packaging markets in towards 2050. So indeed, it's not a degrowth or a zero growth. It's just switching different polymer types for different applications and enabling the green transition, because at the end of the day, everybody agrees that we should go towards net zero and we should decrease our environmental impact to a maximum. Will it be feasible? Yes or no? That's TBD. I'm excited because it's a challenge and I like challenges. If it's just going to be the same for my whole life, I'd get bored. But at the end of the day, I fully agree with your point being we cannot we cannot mandate certain applications to be stopped just based on this polymer type for this application is it's a no-go. And I also agree that sometimes EU policy can be a bit simplistic and based on a certain data set and not taking the full picture, scope 3 into account, for instance. That's a big issue. So I agree. I just want to bring a bit of nuance on the degrowth / zero growth thing.
Did you have a comment on that, Andy?
Yeah, and I don't want to take us off course, but maybe just to come back to degrowth, there is a public policy discussion to happen, as you'll know, because the Green Deal is a growth plan. Yes. It's not a zero growth plan, and most national governments, I think probably all in the EU, are also looking for growth, yes, and are looking for decoupling economic growth with environmental impacts. Yeah. And that's really the mainstream view. And so whilst within that you can say you're growing the sectors that are neutral for the environment and you're decreasing the others, there's maybe still a discussion about whether that's feasible.
Yeah. Super interesting point there. I mean, we could also just walk the plank and then let nature do its course. It's happening already. We are running out of sand for construction purposes, for example. So there will be no more sand, and there will therefore be no more growth because it's based on sand for these applications. And for the circular economy, there will not be enough existing glass or mineral to recirculate into the system to grow our economy. So it will end in a zero growth or maybe degrowth scenario by nature if we continue what we are doing. Yeah. So yeah, maybe that's the way to just think of it. Let's just wait till it happens on its own.
Really exciting, and so happy that we also touched upon the degrowth discussion. And just to turn back to the reality of those owning the buildings today, Nana, I would like to ask, if we are, in terms of measuring sustainability, we're talking about that we also need to maybe use another type of materials with a lower environmental impact. And the question for you is, how do we avoid transmitting a big risk to those owning the buildings when using these new solutions in order to fulfill the climate or environmental ambitions?
So the simple answer is we need to gain experience in using alternative materials. Are we talking bio-based material, recycled materials, or different types of constructions, hybrid solutions? We need the experience, and the best way to get that experience is to maybe apply to smaller projects, to lower risk projects. We work with clients where they have a small area of the building that has a smaller risk, and therefore they can implement other types of materials here as in a type of test phase for them to gain the experience to maybe use it further on. Because as a consultant, I don't take the risk on. If I consult a client and I advise them to use a bio-based insulation material, I'm not the one that actually takes the risk. It's going to be the developer, and it's going to be perhaps even one of my colleagues, one of the other engineers. As a sustainability engineer, I'm not responsible for the risk. So therefore, we need simply to just practice it more. We need to get the experience. And that might be one of the best ways to get it is if private investors actually get invested in this, because that's the way it's going to move the quickest, but also from legislators and from perhaps Realdania or other types of funds that might actually supply the support that we need in order to gain this experience. Because there is a lot of alternative materials are not regulated yet. They might not be able to be compared with, for example, other materials in regards to fire safety or in the structural materials or insulation materials.
I think you're onto something there for sure with trying to practice a little bit. But I also fear that that will keep the building industry in this trial and error mode that we have been in for centuries. So we build a lot of things using a lot of material, and then we figure out, oh, that was not the right way to do it. Let's do it again, but slightly different. We can go much more knowledge-based about it now and make much more tests of the materials from a laboratory point of view, and then scale it up from there. I mean, we have a good example of NGO as a material in Denmark that was costing the society billions, because we just went out and built buildings with it without really, testing it. That was an experiment unseen before. And we risk doing that with the new materials if we just go out and practice. We can and we should test these things. We have all the means to do it and all the standards to do it. So we maybe just need an investment in that part of the equation to say, let's go and test these on an equal basis, and then we can compare the material properties and use them without any risk as a consultant afterwards. So I'm really missing that, especially for the alternative materials.
I think you have a valid point. I also think it's important to look when we do this testing, when we're doing this knowledge transfer to other countries. I know we're in Denmark, and I know Denmark is like the coolest place on earth, and we're the smartest people ever, and all of that. And there's no way that they could ever do anything remotely better than we do it in Denmark, or maybe not. We saw a study on ethics systems and looked at how does it work, and apparently it's difficult to use ethics in Denmark.
Pardon? What was that?
Ethics. That's the external insulation where you put you put something on the facade.
Okay.
Yeah.
So you put insulation and then some plaster on it. Okay. Yeah. That can be problematic. Yes.
That can be problematic.
But it can also work.
we could also look to say Germany.
Exactly.
They've done it for years.
Yeah. No problem.
Maybe they have experts on how to do that. So we can do.
They do.
How do we train people to do it? It sounds maybe crazy, but maybe they've done something in Sweden. I think that's unlikely.
No,
Sweden is unlikely, but other countries, yes.
Well, they have done wooden buildings, and they are looking at us staying and says, "Oh, you are reinventing the deep plate here. That's nice, guys. Why are we not looking at the literature and see what happened 50 years ago and then learn from that?" That's a big problem, I think.
Okay, I would like to give room for a final remark from each of you. I just want to ask, is there any questions in the audience? Yeah.
You talked about degrowth in general and always orientated towards maybe just change from plastic to other possibilities and never do anything to actually degrowth economics. And do you really think that being at this constant rate of growth, it is possible to change to sustainability, and it's not an overall degrowth or overall society rethinking about not consuming as much anymore?
Well, to me that's a loaded question, because it's no. I mean, we cannot go on without degrowth. It's impossible. But I don't know how and when we face that. And that's not me talking from a political point of view. It's just the facts of science that this cannot go on. So I think you're right on that one.
Yeah, because during the discussion about degrowth and stuff, I had the feeling that the main focus was to just switch from maybe not plastic to carbon.
No, that's not enough. For sure, that's not enough. That was my point. That yes, we can look at these things, but it actually also have to degrow. Otherwise, this won't. The ecosystem is not. It's not possible to continue to grow. We will be out of everything, and it will regulate itself at some point. But thinking it as something that we can grow ourselves out of is it's not possible.
That was a comment.
When you say degrowth, I sense a mixture of what is meant by that.
Sure.
Is it economic degrowth, or or is it degrowth in material resources use?
I don't care about economy. I care about the environment.
No, but that's the thing. But,
Yeah.
but that's the thing. When you talk about, and I completely agree with you. No, I completely agree with you. But I think you have a very hard sell
Yep.
when you're trying to say degrowth, and immediately someone is going to say, "Are you implying that our economy should become smaller? That we should not allow, these other people?"
Yes, I think we need a prefix in front of the degrowth. So I'm talking environmental degrowth, and other people might talk economic degrowth, and that's something else maybe. But the economy is just, I don't know. Yeah. Well, we have decided it is coupled. But yeah.
I think it's a really hard sell for you
Yes.
to talk about degrowth when people are going to go directly
to the economy aspect. Well, that's what happened in the Brundtland report. Yeah. That happened in the Brundtland report as well back in '82. That you had the ecologists and the economists fighting about how are we calculating and what is value and all that, and that ended up with that compromise that we have been telling ourselves was the right thing for decades, but it's not. I mean, look at the problems we have. It was the ecologists that should have won that battle. But yeah, that's where we are right now.
And that's why you still have like the Green Deal as an economic growth plan, also to get people on board. Otherwise, it would never become mainstream. So I guess that's the trade-off.
Yeah.
Well, we tried that since the '80s, but nobody really got on board, and now we really have problems, right? So I don't know. In 20 years from now, we have super problems, and let's see what happens, I guess.
And to go back to the overall theme of today's discussion on how we measure sustainability, I would like to give each one of you the opportunity to give a final remark in terms of a good advice on how to move forward in measuring sustainability. And I would like if you could point out to who are you giving this advice? Who's the one who could be able to act? Who is ready to?
I always try to dodge that, like ladies first, but one advice. I think one advice I would give to every company or organization is start working on sustainability. What we are doing as consultants is going to organizations and helping them define their sustainability strategy. I think we as consultants are able to do that at big organizations. But I think every organization within our system should start to think about that. Like you have a finance manager, every company should have a sustainability manager and try to incorporate at least use sustainability as a lens to do business. And that's what I strongly believe. So it's asked to every entrepreneur, every company, every organization to start acting upon that. And the first thing you learn at business school is you can't manage what you cannot measure. So if it gets on the agenda of every organization, every CEO, it would also automatically ripple down to data collection and measurements.
Thank you.
Yeah, maybe to build off that, not to forget about measurement, and also because it'll lead to better outcomes. So you might think that something's more circular, or the companies we've seen who said they're doing circular things, and then you really dig into the data and you discover, as we've discussed, that certain materials are maybe surprisingly better than others in different contexts. So making sure that everything's data-driven, you do that by measuring and following good methodologies, like in our report that you can read.
I think those are fairly valid points. Basically, the only people that should make decision based on emotions are consumers, and if they like red or blue, that's fine. Policymakers and corporations should be data-driven and should make sure that they measure the right thing. Sometimes you have measurements that measure a indicator, but the indicator says nothing about what you're actually trying to achieve. We know, there's a huge discussion on marine litter and how much plastic ends into the oceans, and we measure that by weight. So we say X million tons of plastic ends into the ocean. And how do we measure what type of plastics are going into the ocean? We look at pieces on beaches. Now, those are not the same. So are we doing the right policy to achieve the policy objectives? We don't know, but it feels good. Maybe we should let feelings stay at the household level and then make data-driven decision based on facts and saying, if we do this and want to achieve this, then we should have an actual data point to measure if we can actually do that.
So your advice was for the policy.
Make sure you measure what you're trying to achieve and not go with gut feelings.
Yeah.
Yeah, well, I could go in many directions from here and advise everything from students to policymakers and in between. I don't know. Maybe one thing is to say to everybody that sustainability is not about making it a little bit better than what you do today. It is not. It is much, much more. Have a look at the benchmark, which could be something about the concept of planetary boundary, and see what is it actually we need to do, and how for a long period do we as a society wish to live in a risk zone of catastrophic consequences of what we are doing right now, and then make that into the benchmark of what we are supposed to do, and not just think that doing it a little bit better is enough. And then I don't see that many students here. There's maybe a future one right there, but study hard, gain the knowledge, and then be the change agent in a world that really needs change. Thank you.
Thank you. And then
I think I'll just follow up, and it goes pretty much in sync with what all of you have been saying. In order for us to be able to measure this and to actually gain experience and to move forward is to be transparent. We need, and that goes abroad to every actors, all of the actors in the industry. It goes from consultants being transparent about how they calculated, what is the basis for their calculations, from developers, what products they're actually using, from the manufacturers, what is in your calculation, what is it based on, how are you actually optimizing it? Are you just using wooden pallets, or have you looked into actually optimizing your production? So transparency in order to gain any experience, in order to move forward and perhaps actually be able to measure this properly. Yeah. Thanks.
And thank you all so much for joining this session and following through, discussing both at a very specific product level, but also on the overall perspectives of systemic change and degrowth discussion. Thank you so much. And there are sandwiches over here.